Amine stress corrosion cracking. Description of damage. A. Amine SCC, or amine cracking, is the cracking of steels under the combined action of tensile stress and an aqueous alkanolamine solution used to remove, absorb, H2S and or CO2 and their mixtures from various gas and liquid hydrocarbon streams. B. Amine cracking is a form of alkaline stress corrosion cracking, ASCC. C. It is most often found at or adjacent to non-postweld-heat-treated, non-PWHT, carbon steel welds or in highly cold worked parts. D. Amine cracking should not be confused with several other types of SCC that can occur in amine environments, which are further described in 3.66 and 3.12. Affected materials: carbon steel and low alloy steels. Critical factors. A. The critical factors are the level of tensile stress, the type of amine, and temperature. B. Increasing stress level increases the likelihood and severity of cracking. Cracking is most often associated with high residual stresses from welding or cold working that have not been removed by an effective stress-relieving heat treatment. C. Cracking is more likely to occur in MIA and DEA services, but is also found in most amines including MDA and DIPA, RDEP. D. Increasing temperature increases the likelihood and severity of cracking. However, cracking has been reported down to ambient temperatures with some amines, MIA in particular, other than in special cases, such as where the steel component is completely clad or overlaid with stainless steel or other alloy and the welds are not exposed. PWHT is now commonly recommended for all lean amine systems, excluding fresh amine, at all operating temperatures, regardless of amine type. Some refiners also PWHT-rich amine service equipment, whether for Amine SCC resistance, wet H2S, SSC and stress-oriented hydrogen-induced cracking, SOHIC, resistance, or both. Refer to API 945 for guidelines on PWHT for various amine services. E. Amine cracking is most often associated with lean amine services, where a solution of amine and water is used. The pure alkanolamine does not cause cracking. In rich amine services in H2S removal systems, the H2S helps form an iron sulfide, FAS, film on steel surfaces that helps impede Amine SCC. Cracking in rich amine services is most often associated with wet H2S. C 3.67. F. Cracking can occur in non-PWHT piping and equipment as the result of exposure to steam out and to short-term amine carryover. This is another reason PWHT, for stress relief, is now commonly recommended, regardless of operating temperature. G. Amine concentration does not appear to have a significant effect on the propensity for cracking. Affected units or equipment. All non-PWHT carbon steel piping and equipment in amine service, including contactors, absorbers, strippers, filters, regenerators, and heat exchangers, as well as any equipment subject to amine carryover, are subject to cracking. Equipment in rich amine service is less susceptible than equipment in lean amine service, but not necessarily immune, especially vessels where acid gas is either entering the amine, making rich amine, or leaving the amine, making lean amine. Appearance or morphology of damage. A. Amine SCC cracks initiate on the processed side, surface of piping and equipment, primarily at welds. Cracks can appear in the HAZ and or the weld metal but are most often found in the high residual stress zone, which is typically beyond the metallurgical HAZ, about 1/10 of an inch or more, several millimeters, from the weld. Figure 3 March 2001. B. Cracking typically develops parallel to the weld, and there may be multiple parallel cracks. In weld metal, the cracks are either longitudinal or transverse to the weld. C. At set-on nozzles, the cracks are radial in the base metal, i.e. they fan out from the bore. Figure 3 March 2002. D. At set-in nozzles, the cracks are usually parallel to the weld. E. The appearance of the cracks on the surface may be similar to those caused by wet H2S cracking. F. because residual stress is a driving force for cracking, cracks can occur on the processed side opposite external attachment welds. G. Positive identification of amine cracking can be confirmed by metallographic analysis. The cracking is typically intergranular and oxide-filled with some branching. Figure 3rd March 2001 and Figures 3rd March 2003 to 3rd March 2005. Prevention mitigation. A. Carbon steel welds in piping and equipment should be stress relieved in accordance with API 945 and NACE SP 0472. The recommended minimum stress relief temperature is 1175 plus or minus 25 degrees Fahrenheit, 635 plus or minus 15 degrees Celsius. The same recommendation applies to repair welds and to internal and external attachment welds. See Figure 3-3-6. For local PWHT, recommended heat treatment bandwidth is listed in NACE SP 0472 with reference to WRC 452. B. Consider using solid or clad stainless steel or other corrosion-resistant alloys in lieu of carbon steel. C. Thoroughly water wash non-PWHT carbon steel piping and equipment prior to welding, heat treatment, or steam out. Inspection and monitoring. A. Wet fluorescent magnetic particle testing, WFMT, alternating current field measurement, AFM, and eddy current testing, ECT, can be effective techniques to detect these surface breaking cracks. Proper surface preparation by grit blasting, high-pressure water blasting, flapper wheel abrasive grinding, or other method is required to remove scale and contaminants. The method of surface preparation is dependent upon the specific technique. B. Angle beam, shear wave ultrasonic testing, SWAT, and phased array ultrasonic testing, POT. Ultrasonic techniques can be effective to detect and size cracks and would be the methods typically used for piping. However, caution must be exercised when interpreting results on piping welds that have not previously been inspected with angle beam UT, SWAT or POT, as it may be difficult to distinguish SCC from original fabrication flaws. SWAT and POT can also be used to periodically monitor crack growth. C. Liquid penetrant testing, PT, may be used but should not be the only means of detection. PT may not be effective in finding tight cracks because the cracks are oxide-filled. D. RT may not be effective in detecting fine, tight cracks. E. Acoustic emission testing, AT, can be used for locating cracks and monitoring crack growth.